like realized is that we can't just like ship notebooks to them and say like, okay, you can like run this every day and then you have your solution, and we're off to the next guy who needs us. So the end users of the applications were actual like maintenance engineers who were in the field, who needed insights on a real-time basis, and who actually had a lot more benefit from like dashboards and live applications than from just our code. So that's something that we needed to solve. So they needed an application with basically our data science stuff running in the background. So for us, that meant that we actually needed to take all the bits and pieces of the analytics we were developing, usually like our Python code, and move it to a live environment. And yeah, this needed to be in the cloud, and it needed to be scalable, because when they wanted to connect more assets, for instance, our code also needed to scale to process more data. And yeah, we also couldn't say like, okay, the application is down for one day because we have to do like maintenance, or we have a new model that we need to deploy. So like a lot of different challenges were coming into play, and we needed a solution to take care of that. And we also realized that our application was not just an AI model, but usually also had like some data pre-processing code around it. We had some stuff with web scrapers that we needed to parse data from. Sometimes it was not actually that much of AI or machine learning, but just like some statistical models or other types of analytics. So we had all these different bits and pieces that we needed to put together into one coherent thing. All right. So the challenge with that was, so how do we run these jobs continuously, but also who is responsible for actually deploying and maintaining everything that's there? And at this part, we were just like a team of data scientists. We didn't really have the capabilities on the IT or software side to make this happen. So our team was spending more and more hours on really like doing the cloud stuff and building Docker containers and moving it to servers and kind of putting everything together as well as we could, making everything into one active application. At some point, the people on our team were saying like, okay, I'm spending like 60% of my time now on just maintaining the stuff that we have, and like fewer and fewer hours on actually developing new stuff and new models. So what can we do about that? And we realized that this was actually not a problem that we had, but that actually many other teams and companies that we spoke with were running into as well. That at some point there was this kind of awkward handover between data scientists and kind of the software IT engineers. Like, okay, take this code and take this Python code, take these notebooks and get them to work somehow and connect them to the data sources. So we actually said to ourselves, okay, we see this happening all around us. Let's try and see if we can work on something ourselves that could solve this issue for ourselves and have an actual scalable solution with which we can ship our solutions and our code much faster and actually build some solutions and actually applications out of that. And so we started exploring this really like growing field of different tools and open source tools and everything that was out there to do that. So slowly we started putting together some of the some things, and we said to ourselves, okay, so what do we actually need to get this to work? So we want to make it very easy to go from Python code to kind of a live web service, preferably with like an API endpoint or something where we can send data to, and which we can make it reusable, so use it for different applications. They need to scale, like models need to scale, because we had customers with different workloads, different peak loads of data coming in. So that was important. So we can't just have everything on one server, but we need to kind of orchestrate jobs somehow. Also, we needed a form of control to see if everything was still running, and if everything was also still running like during the day, during the night, and kind of see if everything goes smoothly. We also saw that there were a lot of applications, as I just mentioned, that were not just the AI model, but also different pieces of code around it, some pre-processing, some analytics. Sometimes we need to have a web scraper that kind of gets data from somewhere and kind of adds it to the flow. So we also wanted a way to make pipelines and kind of create a sequence of different steps. For our team, it was really important that they could still work with the tools that they liked and that they were working with. So, like for data scientists, usually like notebooks, a lot of local environments still. So not that much cloud-based, but just having local data sets, doing some experiments, and then kind of moving it forward. So we want to keep that. So we wanted to also kind of disentangle this whole serving thing from the development side too. And the last thing, which was the main point, kind of a separation of concerns between the data scientist and IT part, such that the data scientist doesn't really need to know anything about Docker or Kubernetes or any like networking, cloud settings, stuff like that. Just focus on the data science and the platform takes care of the rest. And for the IT and software people, it was important that things were robust, resilient, and always working, such that when a data scientist would deploy something crazy, that it wouldn't break everything that was running. So putting everything together, we spend a lot of time working on a solution for this, but we actually managed to kind of get to the thing that was working for us, which was a platform that could help us really quickly ship Python code, move it to a live service that was running on Kubernetes on a cluster somewhere. We also wanted to make it cloud independent, so that we can kind of move the environment from one cloud to the next, or move it on premise if that was needed. And that's kind of how we came at this at the thing that UbiOps is right now. So we also really pivoted our company from being a data science company to really developing a software product to help other data science teams, which was a challenge, but we managed. And we also don't want to stop just at the serving and deployment part, because we realized that there are a lot of different things around machine learning that's not just about the analytics, but also about a lot of the, let's say, edge cases and things you encounter when you really move analytics to a high-demand environment. So this is about like security things. How do I integrate with like CI/CD processes that are already in my in some companies? How do I take care of control, bit of governance, logging, and also more to the future. How do you, for instance, take care of making sure that your analytics is actually unbiased and auditable, and all these type of things. So there's a big challenge still around this in this whole area that you also see is moving into kind of a theme called MLOps, or machine learning operations, model operations, which it's really nice to see that a lot of people in the industry are focusing on solving this interface between I have some like serving infrastructure and I have my data science code, and how do I kind of connect the two in a good and proper way. And that's what that's kind of our mission, to also help other teams with that. We make it easy for data science teams to ship their code and to really turn their analytics work into applications, solutions, and building something, and also seeing their work actually being used in the field, instead of just being in like an experimental kind of staying in the lab, so to say. So that's what we do. That's what we develop, and that's also where we're at right now. Also see that it's a larger theme that multiple companies and people in industry focus on this MLOps space, which I think is really great to see. I think it's important for kind of the data science community in general that we're kind of making the step to moving really from just the analytics and the nice presentations to showing that this can have a big impact in the real world. So thanks for listening. Thanks for joining. We're having a workshop later at 2 o'clock. If you're interested in joining, we're gonna showcase our platform. Basically, you can work along with us. We're gonna deploy an image recognition model. So if you're interested, feel free to join. Also, me and the team will be around here and happy to get in touch. And looking forward to meeting you. Thanks for listening. Lots of time for questions. Okay, that's really good. Any questions? Yes.
Thanks for the presentation. I think you have a really interesting product. How did you go from eating your own dog food, as they say, as a product, to actually serving customers? What were the biggest challenges in that?
Yeah, of course you see that. It's a good question. So, question was, what were the biggest challenges in basically going from eating our own dog food and having a solution that worked for us to something that works for multiple companies and customers. So I think the biggest challenge is that a lot of data science projects are very diverse, and you have a lot of edge cases. So for us, it was a challenge to see, like, okay, what can we kind of generalize and what's really specific for this kind of customer that we're talking right now, and is giving us some feedback on the platform. So really making something that works for everyone on a certain level is and still remains the biggest challenge for us. And we're always really happy to get feedback on this, and we try to listen to customers and users, of course, to kind of make that work. All right. Yes. You mean before, before we had this, or right now?
Right now. So when you are building it in the cloud, and how is the workflow? Is everyone assigned a separate role or something?
So what we do is our platform basically is a whole set of different services running on Kubernetes. So we have different teams and responsibilities working on certain services. So we have the service that kind of builds models into their own Docker containers and deploys them. We have a service that takes care of data routing and pipelining. We, of course, have a large part that's just like infrastructure, Kubernetes type of stuff. So usually we have different responsibilities in different teams. So that's kind of how we divide the work. And of course, kind of a really well-defined development workflow. So, all right. Yes. Oh, yeah, over there.
Hey, great presentation, and I think it's a really interesting problem. I was wondering, so we have already established companies in the space like MLflow, cave surfing, and things like that. So
yeah.
How do you differentiate yourself from that? Because I think we have like so many platforms coming out. So
yeah, for sure.
How do you position yourself?
Yeah, very good question. We also see, of course, that this field is like booming at the moment. There's a lot of activity in open source, kind of MLflow, KF serving, as you mentioned. Now, these two specifically, like MLflow, is more for, let's say, experiment tracking and getting a good, understand correctly, like a good, kind of versioned way of doing experiments and kind of packaging this and moving it to the next step. KF serving, of course, you need a lot of Kubernetes knowledge and stuff to get this to work. Same for Kubeflow. So we are really offering a managed solution, and we try to stick to the serving deployment part, making this really easy, and offering you a way to also run more code than just really the AI-related things, but also the bits and pieces that come around it, and move this into pipelines and things, and running this as basically single services. So, okay, thanks. Yeah.
Hi, thanks for the presentation. My question is about IP. So, for example, if the data science, if the company wants to use your platform and upload the model, which is sensitive information, or wants to keep it within the company, so how are you dealing with this, with the ownership?
Yeah, good question. So, yeah, I was. Yeah, thanks. So, question was about IP ownership. So, if people deploy code to us, how do we manage that? How we manage intellectual property? How do we keep it secure? So, there are a couple of angles to this. So, first of all, of course, like the code you upload, that's nothing for us to touch. We just provide you the serving infrastructure. There is also, we see that in certain industries, of course, this is very sensitive. So in that way, we can also install the platform basically in your own environment, so that everything kind of belongs to you, keeps belonging to you. And yeah, we have we put a lot of emphasis on security and certification and things to make sure that both your code and your data is well protected. We also have a permission and role system that lets you manage. Also, if you collaborate with others, like in your team or in your organization or with other organizations, that you can manage who can access basically the code or who can access the data or who can use the model. So in that way, you can kind of manage this well. Okay.
No more time.
No more time? We're out of time. Happy to answer any questions later, by the way. We'll be around.
Many thanks, Victor. That was elegant. Give him a warm applause for that.